Today we are doing three things: matrices, determinants, and probabilities. Let's start with the matrices. So a matrix is a mathematical object that is made of arrays, right? Like this, let's say A, B, C, D. These are the arrays, and these are called the rows. These are the rows of the matrix, and these are the columns, okay? These are the rows and these are columns, okay? So we have rows and the columns. That's how and A, B, C, D, they can be any real numbers or complex numbers or any number entries. And the next thing that when we look at here, next thing we need to know is okay, so the next thing that we need to know is dimension of the matrix. So, okay, so to measure the dimension, what we need to do is to measure the dimension of a matrix, we need to know its number of rows and its number of columns. Let's say I have something like 1, 3, 5, 7, 9, 2, something like this. So if I want to know its dimension, I need to know how many number of rows it have. Right? So let's say this one have 2 rows, 1, 2, 2 rows, and 1, 2, and 3 columns, right? So 2 rows and 3 columns. So we write it as 2 cross 3. So its dimension is 2 cross 3. 2 means 2 rows and columns cross R cross C. So rows cross the columns. Okay, and the elements that are inside there, let's say this one, and in any number inside there, any entries, these are the elements or entries of the matrix. Okay, so now let's see. If I have a matrix which is, let's say, just 1, I have written 1. Okay, it have 1 row and 1 column. It's 1 cross 1. Let's say if I have something, let's say like 1, 2, 5, 3. This one is 2 cross 2. Right? Similarly, we can have 3 cross 3. So the matrices that have the same number of rows and the same number of columns, they are called square matrices. Square matrices. They have same rows, same number of rows, okay, and columns. Oops, sorry. Then there is some different specific types of matrices. The famous one are like this. They're called these are called the identity matrix. Identity matrix. It's represented as I, and it's 2 cross 2. Okay, so it's 2 cross 2 like that. So these are identity matrix. There is a null matrix which is like 0, 0, whose all entries are 0. That one is called a null matrix. Okay. Null matrix. It have all the entries as 0. Okay. It can also have like this one, this one. They are different. This is 1 cross 1. This is 2 cross 2. Okay, they're still the null matrix, but they are different. Then as we can do some operations with numbers, we can do some operations with the matrices as well. Okay, we usually represent some metric by a name capital letter A. Let's say A is a matrix. Okay. A is my matrix. A. Okay, I'm giving them just the sub A1, B1, C1, and right. And I have a matrix, another matrix B. Okay, that I name as the entries of this one is, let's say, A2, B2, C2, and T2. The two just A1 and 2 to just distinguish between them, that it is member of element. A1 is the member of matrix A, and A2 is the member of matrix B. Okay, so how we, first of all, we can see how we address any entry. Let's say I want to look there. I want to see its address. Its address is use the small aij, all right, or small entries. Okay, let's say, so that this one is an A small entry. This one is 1, 2, right? You can say A1, 2. A1, 2 means first row, second column. Okay, if you want to identify, like mention any element, let's say in B, I want to mention element in B, let's say this one. I give this address as B2, 1, because second row, first column, B2, 1, like that. And in general, when we have a general matrix, we use, in general, we use it like A, I, J, where I is row and J is equals to the number of column. Okay. So the next thing that we see is we look some operations with the matrices. Okay. So let's say we add them. Okay. Addition and subtraction, they are kind of same. Addition or subtraction. So let's say I have a matrix, just taking an example, okay? Let's say my matrix A is 1, 3, 7, 2. And the matrix B is 2, 1, 5, 9. So first of all, we can add them, A plus B, right? So A plus B, how we add them? We add the corresponding entries. So this number will add up with the corresponding entry in this one. So 1 plus 2, 3 plus 1, 3 and 1 will add up. And 7 plus 5, yeah, here. And then 2 plus 9, okay. And then you can add them, combine the numbers. So 1 plus 2 is 3. 3 plus, let's say, 4. 12 and 4. So like that. Okay, so this is our addition of matrices. Let's say just question here. So let's say I have a matrix A, which is 2, 1. Okay, this is the matrix of order 1 cross 2, 1 row, 2 columns. Okay, and I have a matrix B, which is 2, 3. Okay, so this is 2 cross 1. So 2 rows and 1 column. So the question is, how we will add them? Okay, so because now the entries don't correspond to each other, all right? So in those scenarios, when you see the entries don't correspond to each other, you cannot add them, okay? You cannot add them or subtract them. You can only add or subtract the matrices that have the same dimension, okay? Can only add or subtract, okay? The matrices that have same dimension, or also the order. You can also say the order of matrix or dimensions of matrix, same order of matrix, okay? So, all right. So addition and subtraction, they are basically same. In addition, you just add them, and in subtraction, you just subtract them. Okay, the next thing is that comes to mind is the multiplication. Okay, so matrix multiplication is not as simple as the regular multiplication is. Okay? So let's say we have, again, let's take two matrices. Okay, or before we take, let me just give you, okay, let's just first explain a little more. So to multiply a matrix, what we need to look at the order or dimension. These are the same thing, same dimension of the matrices that we are multiplying. Okay, so the rule is that, let's say we are multiplying A and B, right? A and B. So the rule is the number of columns of A, okay, the number of columns of A should be equal to number of rows of B. Okay, let me give you an example. Let's say we have A equals to 2, or in general, let's say a general matrix without the numbers. Let's say I'm just having the entries. I'm just representing them. This is A1. Let's say this is, I write that with its name A11, first row, first column, A12, the first row, second column, A21, okay, and then A22. Let's say I have this. The A22 represents second row, second column, and it's the order of this matrix is 2 cross 2. Okay, now if we have another matrix B, okay, so what we said, the number of columns of A, its column is 2. It should be equal to the number of rows of B. So we can have B11 and B12. All right. Oh, sorry, not 1, 2. B21, because row and then comes the column. All right. So let's multiply them. Okay, so to multiply them, what we need to do is we pick the first row. We pick a first row from here, and then we multiply it with this, like place in front of this column here and multiply it with there. All right, so like this. So let's do A, B, we are multiplying. So what we will do, okay, let's just write. So this is A11, A11. It get multiplied with B11, the first number here. A11, B11 in between. We took the next entry, which is this one, A12, and it gets multiplied with this second entry there, B21. Okay, then you add them. That's just done. All right, for the first row. Similarly, you pick the second row from there, and then you multiply with this column with the corresponding members, like so A21 and times B11, the first entry, then plus and A22 times B21. All right, so now let's just expand it a little bit more. Okay. Now let's say if I have one more row, in this, let's say the next row will be B12. Okay, sorry, next one more column in B and B22. So once we are done with this, okay, so again, look at this back, first one. The first row, first we multiplied it with this one, then we give the entry place, and then we take the first row again and we multiply it with this second one, and it will come here. So A11, A12. Oh, no, sorry. A11, B12. This one will go here. First one will go there times there. And then second one plus the second entry, which is A12. And then this second entry here, which is B22. Okay, wait a second. I think it's a question. And then we again, now we're done with this. We again now for the second row here, we pick the second row. We'll pick this second row there. See? And we multiply it with this second column here, similarly. So A21 and then times B12 and A22, then plus in between, plus A22 and B22. Okay. Like this. There is one more thing about the matrix multiplication, that A multiplied by B, it is not same as B multiplied by A. It is because of, there is many reasons, but one of the very clear way by which you can see, let's say our matrix A is the one that we took about. Let's say that is A is a matrix which is 2 cross 2. Okay, A is 2 cross 2, and the B that we are multiplying it with is 2 cross 1. Okay. Okay, so then let's say we change it. All right. So you see the number of column and the number of rows, they are same. The column of first one is same as the rows of the second one. But now let's write it other way around. 2 cross 1 for the B, and then times it with a matrix which is A 2 cross 2. All right. So you see the number of column is 1 and the number of rows is 2. So they are not same. Number of columns is not equals to rows, but here the columns are equal to rows. So this one we can multiply. We can multiply this one. This multiplication can be done but this multiplication is not possible because the columns are not equal to the rows. So that's why we you can clearly see that A times B is not equals to B times A. It can be in some special cases, but in general rule, it's not true. It's not like other mathematics, like 2 times 3 is equals to 3 times 2. Okay, it does not work like that. So we can say that matrix multiplication is not commutative. That's the mathematical term for it. Okay, so all right, so there is the matrix identity matrix that I told you before. Let's say that we have a matrix I, identity matrix. It's 2 cross 2, I 2 cross 2 identity matrix. Right? And we take any matrix B or A, but we can give the name whatever we want. And let us give any number, 2, 3, 4, 1. Right? So let's check. It is a 2 cross 2. And this is also a 2 cross 2. So the number of columns is the same as the number of rows, right? So we can multiply them, all right? So let's try I times the B, or I cross B, okay? We are multiplying them. Or even we can just write it I, B. It means they are getting multiplied. So let's write I. So we will follow the rule that we decided. We take the first row of the first I, first matrix, okay, first row of the first matrix, and then we will multiply it with the first column of the second matrix. So 1 times 2 plus 0 times 4. Okay, again, pick the first row and multiply it with the second column. 1 times 3 plus 0 times 1. Now we come to the second row, pick the second row and multiply it with the first column. 0 times 2 plus 1 times 4. Again, the first row, second column, 0 times 3 and 1 times 1. So let's just add them and see what we get. So 1 times 2 is 2 and plus 0 is just 2. Okay. And then 3, 1 times 3 is 3, plus 0 is just 3. And then 1 times 4 is 4. And the 0 times 2 is just 0. Similarly, 0 times 3 is 0 and 1 times 1 is 1. So you see, this is the original matrix B that we started with. So that's why it's called identity matrix. It's like a 1 in matrices. Just like if we do 2 times 1 in other numbers, we get 2, right? So this 1 is the identity because it do not change the identity of this number. Similarly, this identity matrix, it do not, when you multiply it with some matrix, it do not change its identity, right? So it remains the same. It remains unchanged.